this last part of this video, this is part 2 of 3.2, it just covers the remainder theorem. Now, if you recall, in our last question, it was a U-turn. It was kind of fun in that we got a remainder, so that means it divided out equally. So if you were wondering, I wonder if it's going to divide in evenly or not. Up until now, we would have had to do the entire division and to find out what the remainder was. Although, synthetic division, once you get used to it, is pretty quick. Well, there's even another shortcut, a fast way to find out whether or not the remainder is equal to 0. So here is how it works. X minus a is a factor of a polynomial if p of a is equal to 0. In other words, if you put it in x minus a form, and if you plug in an a into the polynomial and you get a 0 as a result, you know that it is a factor. Well, let's try this out, and we're going to do a couple examples, and we're going to sort of test how this works. So first of all, we're going to do it by synthetic division, and then we're going to use the remainder theorem. So here is our polynomial we're going to use each time, and we're going to use synthetic division. So we're going to do two examples, A and B. So in this case, my A value is going to be equal to -1. Here, my A value is going to be equal to 3. So I will use synthetic division, and if I have x cubed minus 5x squared minus 17x plus 21, I will have a 1 for my x cubed, a minus 5, and then a minus 17, and then a positive 21. And when I draw my L-shaped thing here, and I'll put a -1 there. I'll just zoom in a little bit so it's easier for me. So I dropped the 1 down. I multiply that times -1 over there. My -1 and -5 and -1 combined together give me -6. Now these two multiply together give me a positive 6. I get a -11, and then I multiply -1 times -11, and I get 11, and so here I get a 32. So my remainder here is 32. Okay, so this gives me additional information. It also tells me what my quotient is, right? It's x squared minus 6x minus 11 with the remainder of 32. So how does the remainder theorem work? Well, going back to my original polynomial over here, you know what? It takes a bit of an effort, but I'm going to rewrite it over here. I'm going to say p of x. Oh, maybe not in red. P of x is equal to x cubed minus 5x squared minus 17x plus 21. And now I want to plug in, see what this says? If x minus a is a factor, then I'm going to plug in an a. So I'm going to plug in that -1. So I'm going to say, okay, then I'm going to evaluate it for when p is equal to -1. So I'll get a, wherever I saw an x, I'm going to put in a -1. So I'll get a -1 cubed. Now minus 5 times -1 squared minus 17 times -1 plus 21. Okay, so it's a bit of work here to figure out my positives and my negatives. -1 cubed will be -1 minus 5 multiplied by -1 squared. So -1 squared is a positive, times -5 will be -5. This will be plus 17 and then plus 21. And when I put those all together, I do get a 32. So see what happens if I plug in my a value, I get the remainder. So the exact same answer. I don't get all this other information, but I do get the remainder. Now let's try the other example. So looking at when we divide by x minus 3. So first of all, we're going to do our synthetic division, and it's kind of nice because we've got the polynomial written here. So for synthetic division, we'll have a 1, and then a -5, and then a -17, and then a 21. And our a value is going to be equal to 3. So I bring down the 1, multiply times 3. I get a minus 2. 3 times minus 2 is minus 6. Now add together a negative 17 and a negative 6, so I get a negative 23. I multiply that times 3, so I get a negative 69. Now the math is a little bit hard, 21 and a negative 69, so I get a negative 48. So the only thing I'm really interested in here is finding out what the remainder is. So there's my remainder of minus 48. Now I'll try doing this with my remainder theorem. So I'll do the same idea and I'll say, okay, so using the polynomial, and I won't write it out again, I'll just look at it over there, and I'm going to put a 3 in there. So instead of x cubed, I will have 3 cubed minus 5 times 3 squared minus 17 times 3 plus 21. Alright, so 3 cubed is 27 minus 5 times 9, which is 45, minus 17 times 3, which is 51, plus 21. So at this point it's probably easier to get my calculator out. What I like to do is put together my positive values, the 27 and the 21 there, so that would give me a 48. Minus 45 and 51, that gives me a minus 96, which would give me a minus 48. So here we get the old same. Alright, so regardless of which way I do it, I can get the remainder. So just a reminder, how this works is the remainder theorem is if you have a polynomial and if you're dividing by a binomial and you put it in the form of x minus a, if you plug in the a value to the polynomial, what you get is the remainder. So you know that the remainder, you know that this binomial is a factor if it comes out as 0. So here's your homework. Good luck. We'll see you in class.